We're here. We'll reach the autumn equinox point in 11 weeks. Venus appears in the evening every 20 months or so, just after the sun sets. Venus circles on the next orbit in from us. Venus is an inner planet between Earth and Sun, so we never see it far from the Sun. As you see, it moves faster than we do, 8 months to revolve completely around the Sun. On Earth, we take 12 months. Sometimes we see Venus to the right of the Sun, and then after a few months to the left of the Sun. At this point, it's visible in the evening. When you look at Venus with the naked eye, it's just a little shiny dot, like the other planets and stars. But with very powerful binoculars or a telescope, you'll be amazed to see Venus as a crescent like the Moon. Why is this? As Venus is nearer the Sun, we see it lit on one side, like the half moon. On the evening, take a good look at Venus, our sister planet. About every 5 years, just after sunset, you can see the solar system lined up. From left to right, Mars, the Moon, Venus, and Mercury, if there's no mist, and the Sun, which we can picture just below the horizon. All the solid planets in the solar system are gathered together before our eyes and easy to find next to the Moon. A month before, the Moon showed us the same alignment, except that Mercury was to the right of the Sun under the horizon. In the meantime, Mercury, the planet closest to the Sun, has covered a third of its orbit to move between the Sun and Venus. Venus, the Earth, and Mars continue on their way. Venus a little faster, and Mars a little slower than us. The Moon, very near the Earth, seems to be part of the family of planets, although they're 600 times further away. This alignment clearly shows you the plane where the planets and the Earth circle around the Sun. At a glance, the Sun, Mercury, Venus, the Moon, Mars, and the Earth show us half of the solar system. Every 20 months from week to week, we see more of Venus in the evening sky. Why? Every day, as the Sun crosses the sky, it's followed by Venus, invisible in this blue sky. When Venus follows the Sun very closely, in the evening, as soon as the Sun has set, Venus also drops below the horizon, so Venus remains invisible. Now Venus moves further and further clear of the Sun. When it follows the Sun at a greater distance, Venus crosses the sky an hour later. After the Sun sets, Venus has time to shine for an hour before it sinks below the horizon too. Venus is so bright, you can sometimes see it during the day, if the air is very clear, in the desert or mountains, or if you're flying. Why is Venus so bright? It's near us, so it seems larger than other objects, which are further away. Jupiter is further away and dimmer. Like Jupiter and all the other planets, Venus reflects sunlight. It doesn't shine on its own. In fact, it reflects a lot of sunlight, partly because it's closer to the Sun and catches more of its rays, but also because it's covered with a thick layer of white clouds, which efficiently reflect the Sun's rays. These clouds hide the surface of Venus. It took space probe radar to reveal this Venusian landscape. It's hot enough to melt lead. The soupy atmosphere prevents accumulated heat from escaping into space. This is the greenhouse effect. We also have the greenhouse effect on Earth. Our atmosphere slows our loss of heat into space, though less than on Venus, and protects us from excessive temperature swings from day to night and from winter to summer. On Venus, there's no summer or winter. The sun's rays always strike at the same angle, because Venus's axis is almost vertical to its orbit. Under the clouds, Venusians, if there were any, would never see the stars, or even their neighbor, Earth. But Venus has another peculiarity. It rotates in the opposite direction to almost all the other planets, and very slowly. The Earth takes 24 hours to rotate on its axis, and Jupiter 10 hours, but Venus takes 8 months, slightly longer than it takes to go around the Sun. What's happened? The thick atmosphere surrounding Venus has a tidal effect, like the tides in our oceans. The pull of the Sun draws Venus's atmosphere into a tidal bulge. Dragged out of shape, Venus slows in its spin. As a result, the Sun has more time to heat this part of the atmosphere, so it expands and reinforces the tidal effect, slowing the planet even more. All these effects build up until the planet's rotation is halted and even reversed slightly. A mysterious phenomenon occurs whenever Venus and the Earth are closest together. Each time we meet, every 20 months, the same slice of Venus is pointing towards us. It may be coincidence, but what if it were a sort of planetary interplay between us and our neighbor Venus?